hopefully Gord's going to come in and go, oh, what's happening?
Is a puzzle in which you're trying to fill a 6x6 canvas with 8 different colors. One of the colors has to have the numbers 1 through 8. One of the colors has to have the numbers 1 through 7, 1 through 6, etc., all the way down to 1. So this one works, and this one works for 1 through 6. And question, does this work for 1 through 7? No, of course not. You're missing the number 4, so that doesn't work. What about this for 1 through 4? Well, there's an additional rule, and that is that you are not ever allowed to complete a 2x2 region with just one color. So this is an all red 2x2 square. You're not allowed to do that. So that's wrong. What about this? Well, this isn't a scratch. And it's not a scratch because whenever you start, let's say you're starting at 5, 2, 3. At 3, you don't know where to go. Do you go to 1? Do you go to 4? You don't know. So it has to be a single scratch. Also, the color's wrong. We only have 8 colors. We can't add a new color, so this is definitely wrong. Let's remove that. What about this? Yeah, this works, this little light blue region. It's 1 to 2, so that works. What about this? No, this doesn't work because this region has got 2 3s. You can't duplicate any numbers in a region. What about this? Well, unfortunately, you've already got a 1 to 2 region, so that's the light blue region, so you can't duplicate. So that's wrong. And that 1 at the bottom, that's correct. We definitely want a 1 there, but that leaves the 4 kind of lying there, not doing anything, so that's not good. Let's look at correct solution. Here we go. So we know that that's correct. Now, take 10 seconds and try to figure out if there's a number 1 through 7 region that you can find. Okay, let's see, and here's the answer. Right there. Okay, so that works. What about a 1 through 6 region? Can you find it? There we go, and that also is correct. What about a 1 through 5 region? There. 1 through 4, there. 1 through 3, there. 1 to 2, there. And we've got our little orange region at the bottom. That also works, so we're going to give that a check mark too. Good. That's it. So now it's your turn. Go off and try to find out if you can solve these. You can project this on your school whiteboard and then get kids to color appropriately, or you can just take this and copy it. If you go onto mathpickle.com, you will find a PDF of all of these puzzles, and that will be under, you just have to look for chalk scratch puzzles. Okay, so there's the solution.
So let's bring this down and see if we can get a PDF and try one of these things. How about that? I suppose I could have prepared just in case backup. Puzzles and chalk scratch and PDF. Hello, I'm getting a beep. So it's a little bit more difficult for me to monitor chat and other at the same time. So let's see. Let's try download. Let's see if I have a Navajo. Is there a new folder?
So Dave, you can
Yes.
only imagine what a regular classroom teacher goes through with students online if things aren't absolutely perfect, set up, internet sketchy. you don't have access to something that the district was supposed to get for you. There's a lot of things that make online teaching difficult, and some of it's not our fault.
Oh, I am so impressed with what you guys do. I mean, we had to do online teaching, you know, it was like, okay, here's spring break. Okay, we give you X a week and there you go, kind of like many teachers across the country. But you've got all of these connectivity issues, and I've heard tales of mailing packets back and forth. So we have to develop a set of pages to send people. Wow, I uh, have such, I am so impressed with what you guys are doing here. Let's see, start and journal, XOUR. So I suppose during break, I should have done this. Gord is wonderful, as you can tell from his videos and all of the work that he does. He's really charismatic and charming and runs great sessions. I don't know what happened and why he's not here with us, but I will, let's see, is there an input? Annotate PDF, let's try that. Yeah. Documents. Thank you for your patience as we go through all of this. Navajo. And we have 1023 teacher workshop. Chalk scratch. Oh, that kind of looks like it. Let's just see what happens if we pick a color and see if I can. That's not quite the tool I want. I want the one that's a fill. Nope. If I don't see in a second the fill tool, I will. Huh. Well, yeah, let's check the highlighter and see if it does it. And maybe I just need to go around. Oh, okay. We'll be able to make that work. So I just randomly colored something a 1. Give me a 1, give me a 2. Oops. Family in the background, I guess. We've done that with the Zoom too. So does somebody see, so does this 1 look like it should be part of, you know, how big can we get? Should we start small or start big? I think Gord started small on his. You know, some questions are, could we reasonably get to 7 or 8 from this guy? We could go straight down getting 1, 2, 3, 8. We could get a 7 and a 5 and a 6.
Hey.
So that'd be 1, 2, 3.
Dave, I have a question. What's the difference between the black numbers and the gray numbers?
I do not know what
Okay.
his intention was for that. And so, like we said, I am just kind of making this up. I wonder what this tool does. Just switching tools for half a second. Yeah, I don't know. We'll stick with where. Oh, that was kind of funny. So what do we think? Should we try to get an 8? We could get a 1, 2, 3, 7, 8, 6, 5. If I hit a 4, we could make a 1, 2, 3 up to 8, clicking this region here. Then 1, 2, 3, 4, 5, 6 could work over here, so it doesn't exactly kill us. Let's give it a try. Nope. Start with the somebody switched colors.
Oh. Dave, he says on the website, when you bring up a PDF, to start each puzzle, color the 8 bold squares a different color.
So this can't possibly work.
No, so the black, yeah.
So that means that we need different colors here. So let's try a blue here for a 2. Oops. For some reason, my stylus isn't working on this properly. So I'll use my mouse. So let's try making this. See if it'll autofill once I go in. It might. It does. Okay. So then I need a different color. And a different color. And a different color. I may need to find other colors in this program. And a different color. Been shying away from some of the darker colors, fearing that they'll cover things up, but I guess whoever designed the program thought about that, and that doesn't look too dark. You know what? It's light green different than green. It is. So, do you think we should start small or start big? And should we have voluntold or volunteers? Actually, in Pam's session, I noticed we had volunteers. I'm going to try something a little different here just for a second to sort of mix up the dynamics. So, Anne, I'm giving you a job. You are a voluntold. I want you to cheer and say, you are awesome, you rock, give as much positive feedback to the next person I call on. So Anne, would you unmute for a second so we can hear you go woo woo? Are you there? It's an experiment. And Margaret? Yeah, these are funny things with the Zoom. To move this forward, let me pick a different tune here. Sarah, will you cheer your colleague? Can you turn on, can you unmute and say hi? Is anybody out there?
I'm here. I kind of cut out a little bit. What was your question again?
So who is that?
This is Farah.
Sarah. Okay. So instead of asking for volunteers, I am doing voluntold. So I'm going to tell people to do this just so that we get a different slice of participation than the people that speak up. This is something you could do with your students. This, I think, probably works a little bit better in person than it does in class. But Farah, I'm giving you a very easy job. All I want you to do is say, you're awesome, you rock, and encourage this next person that I'm going to call on. And Brooke, are you there?
Sounds good.
Okay.
I'm here.
You're here. All right. So you have your own cheering section here. Sarah is going to cheer you on and give you moral support to help you pick a color, pick numbers, and try to fill this in. So what do you think? Should we start with big numbers, trying to fill in the big numbers first, or should we start with small numbers? What should we do, Brooke?
Big numbers.
Big
Sure,
numbers.
big,
Okay.
yeah. Big.
So the biggest number we got is this 8. So
Okay.
this 8 has to be tied to, so what do we tie this 8 to?
A 2.
Okay, we tie it to a 2. Do you think it should be tied to the gray 2 or to the orange 2?
Does it have to be tied to one with the color?
So eventually we're trying to color a block. And so, who knows? Maybe this 8 is going to get weaved, maybe you'll have to weave through like this, going 1, 3, 2, 6, 1, 7, 8. Wait a minute, that didn't quite work. Kind of my guess is that it's probably going to be one of these colors that are close to it. It'll probably be orange, gray, or red, but I don't really know. I've never thought about this problem, and so we're
Probably the orange too.
tied to the orange too. All right. So then I'll click on orange. And so we have to get each of the numbers 1 through 8. So here we've got an 8 and a 2. Do you want to find the 7, the 1, the 6, 5? What do you want to find next that would make orange?
7.
7. So I see I see only 2 7s here. There's the upper 7
yeah.
and the lower.
Mhm.
Okay, 5 then.
So
There's lots of 5s.
which 7 do we want? The top one or bottom?
That's a lot of orange altogether, though.
Yeah, well, there's going to be 8 orange squares. We have to color squares number 1, 2, 3, 4, 5, 6, 7, 8.
Oh, okay. Bottom 7.
You want to color? What you said? The bottom 7?
Yeah,
Okay.
bottom 7.
So we've got a 2, an 8, and a 7. We need a 5, a 6, a 3. Actually, I think I can see something. How are we going to get? No, well, I guess we could get to. Oh, yeah, I guess we could still get to a 5 or a 3 without cutting things out. So if we're getting to a 1, there's 2 different 1 choices. We know we're avoiding the 7. If we're going to get to a 6, how do you think we're going to go to get the 6?
Diagonal.
Was diagonal allowed? I think this is going to be the 6 that we have to use, but when I saw his pictures, I didn't see any sort of disconnected squares. Seemed like squares always connected along edges.
Okay, so then it could be the bottom left corner. And if we could do 1 and 4.
That's a nice idea. That's right.
Yes.
Which we
Good
also
job,
could have got to this by going 1 and 6 here, but sure, let's try this.
Oh, and then the
Bottom
5
left.
next to the 2.
There's a
And then we have
5
all
next to the
orange.
2. Sure, so this gets us a 1 and a 6 and so then we've got 2, so we've got, I think I've heard those claimed. For this 5.
And then the 3 next to the 6 and the 4 on the bottom. And then we'll have 1, 2, 3, 4, 5, 6, 7, 8. All
Sure.
orange.
So
they're all
that
touching.
is an allowable orange square. I don't
Yeah.
know if it's going to work or not, but was that Sarah doing her cheering? I love the yay. That's
Brooke, woohoo.
woohoo. All right.
They
I feel
worked.
sorry for who has to go next, though, because I don't know if you can get any other colors altogether.
Well, I mean, so how big could this red 1 be if this orange was our selection?
Not very big, just 1, 2.
Seems like so, sure. If this orange is correct, then this has to be 1, 2. So let's color this. And we can keep going. And one of the things that would help is if we kept a record. Of course, we're recording it with video, so we can go back. And if we discover that this didn't work with the orange, we had some choices. Like we could have went to this one in a 6 here. We could have hit the 7 up top. So we have to think a little bit. But if we color this orange, this 1, 2, or 4. So I think we said bigger numbers. Should we rotate in? So Brooke, you were doing, you were forced. Maybe, do you want to pick somebody else? What a horrible thing. You have punishment up for next person.
I'm trying to see if I can find the participants because I can't see them. Let's see. Let me go look at the list here. Nope, that's chat. Oh, there we go. I don't know who's up and ready for this. Ollie, how about Suzanne. Would Suzanne be up for it? Because Suzanne has the most amazing dog picture.
Okay.
Yeah.
All right. I was looking at the orange and we can't change it right now.
We could change it especially if you have a reason in something that says, no, this is not going to work, then in fact we should change it. Though I don't yet.
I was thinking about instead of picking the bottom orange, 3 orange, because there's 3 on top right next to each other, and we can't have that. I mean, we have to pick the one that's above the 2.
So you're thinking that we have to pick one of these 2 3s, otherwise we're going to get into trouble.
Yeah, and the 5 that's between the 3 and the 2.
And the 5 that's between the 3 and the 2. Here, yes.
Yeah.
And what about that?
I thought maybe that 5 and that 3 could be orange.
So let's see if I can figure out how to erase. Then well,
we need a 3 down at the bottom for that 2, and that 2 in the gray, and that 1 that's in the somewhere close by. And then you will erase the 5 over to the left. I don't know if this is going to work, but and then so in the red, could we pick that 1, 2, 3, 4, 5 in a row? No?
We could. Which, one of the things that you're doing, it's kind of like if you've ever been into the store and you grab something on the shelf in the dollar store and you think about, well, do I want this or not? Well, I'll hold it. Then you walk around the store and then you decide, well, I've been holding it. Hey, it must be mine. So you end up purchasing it. You know, you're halfway there. In a math problem, after you start down one lane, it starts getting difficult to give it up if you aren't, you know, so this is a difficult change to sometimes make. So props for this. We've got 1, 2, 3, 4, 5. For our 8, we've got 1, 2, 4, 6, 7, 8. We need to have a 3 and a 5, and you suggested that we add these two. Another comment that I want to point out, and this is really, really important, is sometimes students and parents might ask you, why do I have to learn math? Gee, why do we have to do this? And, you know, I've got a calculator, I've got a smartphone, and to some extent, hey, this is a really valid point. If you want to add the 28 and 365, you can just ask your phone, what is 28 plus 365? And it says, hey, the answer is Joe. But the point is that if you have to think, and there will always be things that come up via whether it's what do you do with water when the animus turns yellow, or how do you fairly decide a land dispute, to, hey, let's figure out a reasonable way to get internet because we need it quickly and we don't want to put power lines all over here. All of these things are problems that you don't know the answer to. You've never seen or worked. This is what we're really trying to teach our students to do, is to be nimble. And so it's really important, in my opinion, that when you're teaching people math, that you show them things that they've never seen before and let them explore and figure out what to do on their own instead of telling them what to do. Does that seem like a good motivation? I will also comment, while I'm on that theme, that it takes a mix. There are certainly some things you need in order to go forward and to learn more problems. So you need to learn how to add and multiply. But doing all or nothing is, I think, a mistake. Doing all math, manipulation, and algorithms misses out on all the rich activities and fun of problem solving that helps you expand your mind. Conversely, if all you ever did was problem solving activities and puzzles, your students wouldn't catch up with what they need to know with algorithms and computation. So, enough preaching. Who's hearing Suzanne? And Suzanne, you want to give us a little bit more? Try to find one more number to fill in.
The 1 through 5 on the top, but then there's a bunch of ones on one side. And
I'm starting to get worried about that a little bit, because I see this red 1 through 5, so we can't have another 1 through 5, and so then what on earth do we do with this yellow? If we made this 1 through 5, you know, I can't make it 1 through 4, or 1 through 2, or 1 through 3. It either has to be 1 through 5, or 1 through 6, or 1 through 7. But is there any legal way to connect this 1 up to 6 or 7 with what we've got?
1.
I'm looking for this.
Is see how we've got, I believe this, we've got a proof that this can't be right, which this is the Sherlock Holmes, right? If you find everything that's not possible, you're left with what's possible. Do you see why I'm saying this is not possible? Because if we were going to fill this in, this can't be a yellow 1, 2. It can't be a yellow 1, 2, 3 because the 5's getting in the way. It can't be yellow 1, 2, 3, 4 because the 5's in the way. It can't be 1, 2, 3 through 5 because we've already got that. You can't get it to 6 because we'd have to click this 1. And we can't get, and there's only 2 6s, and there's no way to get one of these without going through there. So this is wrong. And so do we want to change the orange or the red?
5, 4. Oh gosh. I guess we should have, after starting with the 8, we should have started with the 7, 7, 6, 5. But I can't see a 4 next. Bottom 7 maybe. So the orange 7 should be the top 7.
So maybe make this 7 into a top 7. Okay. The one question I'm going to ask is, yeah, that might change us up on the. So let's try getting rid of that. Whoops. Then we can try making this a 7. One of the things that I'm looking at is when we fill in this 7 here, we have to hit a 5. I think that's going to give us a good clue.
Yeah, that one.
And so if we were going to hit, so if this 8 goes up to this 2, which seems like a reasonable possibility, it could also go to this 2, but if it goes up here, we hit a 2, then this 7, the 8 has to hit one of the 2 7s. Both the 8 is going to need a 5 and the 7 is going to need a 5. If I pick this 5 here, this 7 is going to have a really long way around. So 7, 1, 6, 2, whoops, I don't think I can get through that way. And 7, 1, 5, 6, I need to get to a 2.
1, 2,
looks
3, 4, 5, 6.
And I'm seeming to see trouble here. I suspect that this 5 is the wrong 5 to put with this 8. For that matter, I think that this 5 probably goes with this 7, and this 7 probably goes with this 8. So this might tempt me to try something like this. And
bingo.
then that's going to take out this 5. It's going to take out this, which will then take out this. And it'll maybe make this turn into so that at least we are able to start getting a 7, a 5, a 6, a 2. I'd need a 1 for this 2, so maybe I'd be tempted to come down here. So, maybe a strategy might be to start seeing what things might collect to. So I could maybe make this purple color here. So 1, 6, 7, 5. Is that going to work? Or am I messed up with this purple already?
I think it will. We're
How
just
am I going to
missing,
get to a 3?
well, that's the 3 that's right next to the 5 right there.
Oh, I could take that one.
Mhm.
All
But what
right.
about 4? Where's 4?
Where is
4 goes
4?
down at the bottom by the two gray.
Ah,
Okay,
let's try it.
yeah.
But that 2 gray needs a 1.
Oh, that does not look good at all.
Oh,
Yeah.
you know what? I know we could change that. Oh, no, we can't. Your orange doesn't have a 3, so the 3 could be the one above the 5.
For the orange. Okay.
And I think the orange one actually is going to wind up being a gray one. No, it won't. Never mind. I lied.
It seems like the 7 might still connect if we went 7, 6. Oh, no. If we didn't hit this 1, right? Maybe let's take this 1 out. Maybe because we need this 1 to be with this 2. Which probably means this 4 needs to be with that 2. Right? Because there's not, unless this 2 doesn't hit this 1, it'll have to come up and hit this 1 here, which connects it to a 3. So with this configuration, it looks like maybe we're seeing something like this. This 2 would have to hit this, oops. Would have to hit this 1, this 4. And that 3 would be one possibility. Then this 7 that we were hitting and trying to make purple, we could make it hit 3, 5, 7, 6, 2, oh. Maybe I don't hit that 1. Maybe what we do is do like this. Oh, nope. Oh, that doesn't connect up, right? If I'm trying to make this 7 purple, I run into trouble here. Maybe it should be blue. So can we hook to the blue to a 4? Huh. So what do we think, folks?
I think you're going to have problems down in the lower right corner as well.
I seem to remember in one of your sessions, look at corners. Maybe we ought to look at corners for a second. So there's the 8 that looks interesting. I wonder if it's quick clear. There probably is. Oh. You know what, do I have a... take a step. Oh, maybe I took out too much. Let's cover the different squares, but
Are you going to gallop? Oh, you guys just ate.
Seemed a lot easier on the video, huh? So let's look in the corner. If we have a 1, if we have a 3, it has to hit a 1 and a 2. So that, I think, is an excellent clue, because if we hook this 3 to this green 1, we can't use these two 2s. So we'd have to get up to here. So we'd do a 3, a 5, a 6, a 1. I don't see how you could get to any other 2 if we hooked this 3 to that green 1. So to me, it looks like this 3 in the right corner is not dark green. So,
David, can I try?
Can we try what?
I'd like to try the orange one.
Sure. So what do you want to try with the orange one?
Try going from 2 going down to 8.
Okay.
And then to the right, 7.
Okay.
And then continue with 1 to the right
Okay.
of 7.
So I'll fill that.
And then go down to 4. So next to 1. And then 1, 2. And then continue with 5 and 6 to the right.
Then what happens to your 3 in the lower right? So what happens to this 3?
Going down, yeah, that would be the last.
Oh, so 1,
7, 8,
2,
yeah.
3, 4, 5, 6, 7, 8. So that's what happens to that. So you're hooking this 3 up to that 2 that's so very far away. Hey, that's kind of devious. You should give the wah laugh.
I think that dark green one, is it going to be just that's the one all by itself, because it cannot connect to a 2.
I could, from this position, 1, 4, 3, 2. Oh, nope. And can't connect to a 2. Yeah, so if we do this, then this green 1 is going to be the singleton 1. I agree. And in fact, I think this orange thing is, now we start getting forced a little bit. This 1 looks like it's going to have to be gray. Because where else could that gray 2 hit its 1? So.
And then it has to be 1, 2, 3, 4 right underneath it. I think that's 4.
Yeah,
Because
so
everything
the
else
point is,
matches.
where does this 4 get connected? It can't get connected here. And if we tried to connect it up to this one, we'd have to get to a 5, which we couldn't do. So that's going to force this to be a 1, 2, 3, 4.
Which now means red is going to be to 6. Red's
Has
going
to be to 6. In fact, it could even include, so this 4 here looks like it's going to be kind of sad and lonely unless we make it red.
Yeah,
right?
it has to be red. Yep.
Oh, no sad 4s today.
No sad 4s. Karen got it. She found a nice little path.
Yeah. Woohoo! Cheerleaders. So then we could go up to, we need a 5. We'd need a 3, but we couldn't hit a 4. So that kind of forces it. So
I guess we can have 1, 2, 3, 4, 5, 6 for that column, including 4, I guess.
well, we've got a 4 down here that's red. If I make the 4 on top, then this 4 is the sad, lonely 4.
1, 2, 3, 4, 5, 6.
And then the same applies for the blue. We have 1, 2, 3, 4, 5. Up on top
With
of
the blue,
yes. the right-hand
You're
corner.
doing 1, 2, 3,
3,
4.
4, 5. Yeah, going
like
that.
this.
Yeah.
So this
yeah.
4 has to be tied to something. And this 4 has to reach a 5, which means either this 5 or this 5.
Yeah.
So that's a good observation. This
Can
4
we
is
have the
also
green 1, 4, 3, 2, 5, the rest on top?
1, 4, 3,
Green.
2, 5.
But just until 5.
But then where does this 1 go? This 1 would have to hit a 2.
We'll have to go with,
See this yellow 1?
yeah, yellow 1.
I think that yellow 1 needs a 2.
Wouldn't the
And
blue one just be a 1 and 2 only?
Can we have the yellow 1, 3 down, and then 5, 1, 2, 3. There's no 4. Oh, can we include the 4
on the
next
left, which is
that one? So 1, 2,
5.
3, 4, 5, 6, 7.
So,
So what if we 4
Oh.
to the left of yellow? Oh, I mean 1 yellow.
and then put a 5
And then,
and give it a
and then
2. There's 2 different 3s that we could do, but
no, I meant the 3 underneath 1.
I like
Yeah,
it.
that will work,
Not the
I
5
think.
and 3.
And then I like yours better than mine because you're getting the 7.
Yeah.
And then we need a 6 and we need a 2.
6, and then the 2 next to the 6 maybe. 1, 2, 3, 4, 5, 6, 7 until 7.
Yeah.
And then the purple's 1, 2, 3, and then the green is 1, 4, 3, 2, 5, and then the blue is 1 and 2.
Oh my, wow. Woohoo, you guys rock. Cheerleading. So we're saying the blue is a 1 and a 2, and a 1, 2, 3, 4, 5.
Yes.
Okay, then green the rest. Okay.
Good job, everyone. Ooh.
How frustrated would your students be playing with this? Do they get frustrated?
It took about almost 40 minutes.
Yeah. This is persistence, which just as a life lesson, just sticking with something, it's not always easy, is great, which, you know, one of the opportunities you have when you're working with little kids is whatever you show them when they're young, it's just completely normal. I compare my children to some friends' children where, you know, when they were 6 months old, 2 years old, 4 years old, I took them camping because I like getting outside. And we would go out in the woods, and I'd even leave a tent behind. And so we'd just have like a little bag over top of a sleeping bag, and it'd rain, and, you know, it'd be sort of so food, and it was just great. You know, you just tell them that, isn't this wonderful? Let's keep it up. We're going to get such beautiful views. And, you know, we tell them so, and they believe it. And yep, we can play with sticks, and it's raining, and isn't this fun? And, you know, you can show your students, hey, look at what we're doing. We're spending this time, and we color, and we try again, and look at how it evolves, and it doesn't work. If we, you know, there's an age when they are impressionable, and so here's me preaching again. So what do we think? Do we want to try another one of these, or would we like to find a different puzzle?
Let's try something different.
Try something different.
Something new. To learn something new.
Sure. Save file, documents. I'll post this is why I'm doing this. And is there? And there's 23 workshop. Is there an enter and a save? Missing part of a dialog box. You can see how frequently I've used that particular program. Well, I said we'd do a Gordon Hamilton day. We'll get Gord back sometime. Oh, here he's giving us grade levels. We're elementary. What levels have we played with? Should we play, let's make our brain a little easier, which isn't necessarily easy. See what he says about magic 6 and 9. Okay, we can get some cuteness going on for our day. I think there's going to be a way for me to show.
85, 90, 95, 100. And backwards. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Oh my gosh, that was fantastic. You got it again. So this is a little magic trick that you guys can show your parents. And I'm going to put this on the website to teach everybody how to do this little magic trick. Imagine that you are Louis XV's kindergarten teacher. You have to make sure that he wins every game that comes into the classroom. Here's a magic trick that you might use to make him happy. First thing, you ask your students to guess your favorite number. The answer has to be a 6 or a 9, so fake it if one of those isn't your favorite number. Let's say that it's 9. Now you get your whole class to hold hands and to form a giant 9 so that a fly on the ceiling would look down and say, ah, that's a 9. So you distribute your students. Here's maybe 25 students in a big class, and you can see where I've distributed the king. So now we're going to randomly choose a card, and it's a 14. So we are going to count 14 spaces around the king. So around from the head. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now we're going to count backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It worked. So let's choose another one. So that's 14, 19. Okay, we are choosing 19. Are you ready? So again, from the tail of the 9 or the head of the 6, whatever you want to call it, we're going to count. Are you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And back again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, the king is happy. No matter what number you choose or your children choose, it always turns out to be at the king at the end. You can even do counting by 5s or counting even numbers. It will always work. Isn't this magical? The king will be so impressed with you. What number would you like? More than 9, but less than 20.
25.
Well, okay, we can try 25. It is more than 20, but that's okay. We'll choose 25. Are you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. How does this work? Well, look, for example, here we've counted 19. Now, if we counted 2 more than that, so that would be 21, well then think, whenever you're going back around, in order to get back around to the king going clockwise, you're going to have to go 2 more steps clockwise. So instead of going 19, to get back to the same place, you're going to have to go 21. But that's lucky because the number of steps that you're counting back anyway is 21. So it's always going to work. I want you guys to guess.
Wait a second. Did you understand what he just said? Sometimes I have to go back and think. She's describing right now why the puzzle works, why the trick works.
But that's lucky because the number of steps.
Let's go back just a little bit.
Back around to the king. For example, here we've counted 19. Now, if we counted 2 more than that, so that would be 21, well then think, whenever you're going back around, in order to get back around to the king going clockwise, you're going to have to go 2 more steps clockwise. So instead of going 19, to get back to the same place, you're going to have to go 21. But that's lucky because the number of steps that you're counting back anyway is 21. So it's always going to work.
I want to actually pause this for half a second because this is something that is not always done in the elementary schools when people are subtracting. So does this make sense, first of all, what he said? So I want to know that there are people out there. Oh no, it's the zombie apocalypse. Everybody's died and it's just me. Roar, must have brains. Anybody there?
I think so. I mean, to me, it does make sense because if we laid all those dots flat, it would be like a number line too, and we could possibly compare it to a number line.
Ooh, I kind of like that. I'm opening up a different drawing program and drawing here because there's something I want to emphasize and show you about this. That's a really important thing. So thank you for speaking up. I didn't see who said that, but when we take a look at this, one way we could do it, maybe I'm not going to make 19 dots here for a second, but we could have our number line and we could go, maybe call this 0, 1, 2, 3, 4, 5, 6, 7. And if we go out some amount and then we come back, so if we go out 7 and back 5, we could go 1, 2, 3, 4, 5, 6, 7. And then back 1, 2, 3, 4, 5. We end up on this particular king square with the number line. This is a 7 minus 5 equals 2. Instead of going out 7 and back 5, let's do something different. Let's go out 7 plus 3 and go back 5 plus 2. Oh, no, 5 plus 3. Notice what I did here is I put a 3 in both spots. So let's do this on the number line. Let's make a new number line. So we can start at 0 and 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. Plus 1. Let me actually let's make this plus 3. 1, 2, 3. And then let's go back. If we went back 5, going back 5 would have been 1, 2, 3, 4, 5. Or going back 5 plus 3. This is going back 5 plus 3. Yes? Seems like I'm being really pedantic about this and getting this. The number equation that we can see here is 7 plus 3 minus 5 plus 3 equals 7 minus 5. I don't care so much what 7 minus 5 is at this point. We could work out that it's 2 that you get to this square here. The thing that I care about is that 7 minus 5 is the same as 7 plus 3 minus 5 plus 3. Now, does anybody have a guess why your 5th grade colleagues will be very pleased if your 2nd and 3rd grade teachers show this principle? What does this look like to you? Maybe I need a voluntold.
Getting the same numbers.
And this is, there's something, it's not exactly this. And so here I'm teaching something about addition and subtraction. I'm really teaching the property of subtraction, but this property of subtraction looks a lot like something similar.
Like
so
terms.
I'm sorry, you're asking about the results? I'm sorry.
This property right here is an easy thing to overlook in the elementary grades, but
you mean like equivalent expression?
An equivalent expression, sure. So here I'm doing it with the subtraction. What starts giving students trouble later on when they see things that are equivalent, and what has a similar thing?
The parentheses.
Parentheses, yeah.
Parentheses.
Filler appendix.
So suppose I wrote 7 divided by 5. Is that equal to anything else that you know?
No.
Not an easy one to work out. Hint, use the number 3. We could make it a mixed fraction, but even with it as an improper fraction, I can mix in the number 3 in a rather fun way. So how could I put the number 3 into this fraction in different places and have it still be the same thing? So when are fractions equivalent? Give me an example of equivalent fractions. So let's just come back for there. So give me an example of two fractions that are equivalent.
You mean like 1/2 equals, I don't know,
5/10.
6/12 or something?
6/12. And somebody said 5/10. So, yeah. And what did we do to the 1/2 to turn it into 6/12?
To find the least common denominator.
Going this way, we can find a least common denominator, sure. But in going this way, what did we do?
We divide both numerator denominator with 6.
Or using 2.
In this direction, were we dividing? To change the 1/2 into 6/12?
Reduce.
So somehow,
Reduces over 10.
so let's take this with a place second. If I'm making this 1/2, if I make this 587, you probably don't know what goes on the bottom right away. How do you figure out what goes on the bottom? In fact, 58737. There, make it even harder. So what number goes on the bottom? You don't have to, don't tell me the specific number, tell me how you figure it out.
Do you put like a unknown variable there, like an X or a Y or?
We could, but probably not with your 5th graders.
Oh, sorry.
What
You would multiply it by 2?
Yes, this is 2, because this is 1 times 58737, and then it's divided by 2 times 58737. The really important property here is multiply and divide are opposites. So they cancel. And so that means whenever I have, 17 times 41, then divided by 41, I know that this is 17 without multiplying 17 times 41, because these two operations cancel each other out. And this is a fundamental fact about fractions, which, yeah, people are used to saying 1/2 equals 3/6. Maybe as soon as the numbers are a little bit bigger, when I write 1 times 4873 over 2 times 4873, and these are time signs, it's easy to see, oh my God, scary big number, not, oh, the opposites are canceled. But this is a really critical thing that a 5th grader should notice, is that you can have different ways of writing a fraction. And that, for instance, if you're doing arithmetic, another problem that's along this ilk is, imagine that I was asking the student to simplify 13 times 482 divided by 482 times 39. I would hope that the students would first look at this and go, oh, that just cancels. Many students will just multiply this the way they see it because it's the ordered put and miss that. And in fact, even further, I would hope that then they would look at this and say that this is 3 times 39. In order to prepare your students for this material where everybody goes, oh no, fractions, and to help your colleagues who are teaching 4th, 5th, 6th, 7th grade, fractions kind of last for a while, to see that this concept is very much the same. How does addition relate to subtraction?
Crossing out the numbers that are the same.
Yeah, you see that this 3 and this 3 cancel. This equation is exactly like 5 divided by 7 times 3 times 3 equals 5 divided by 7. But this is an example that you should be teaching when they're seeing subtraction so that they get used to the idea of opposite canceling out. And what I claim Gord has in this particular magic trick that we've been watching is exactly this argument where he first adds and then subtracts. If he adds and then adds an extra 2 and then subtracts the same extra 2, you get back to the same spot. And if I add an extra 15 and then come back, I come back to exactly the same spot because this extra piece that he's putting right here, I don't see if you see my pointer, comes there and back.
Yes, I see it.
So I'm just checking because I'm losing track of when we said we would stop. We said we'd go to 12. So I'm sort of over the time, and my Gord Hamilton imitation wasn't quite as good as seeing him in the flesh, as it were. We will get him out in the flesh. I could continue to play this video if we wish to hear it. It would take us another 3 minutes and 10 seconds. I will certainly put a link to this and to the color scratch on the webpage. I'm going to be a little at your service here. So what would people like?
I'd like to hear the rest of it.
Okay. So I will take half a second because I always worry about not getting people their money and certificates to remind you the house cleaning issues of make sure we're able to contact you. So filling out the form is a good way. Say hello in the chat to make the accountants happy. Hi, bean counter. If you don't have a W-9 on file, send a W-9. I think that's, and keep an eye out. We will have Jim Tanton. He will show up, and let's.
I want you guys to guess my favorite number. What do you think? Two things that you have to keep in mind for this magic trick. The first is that you have to look at the arm of the 9 or the arm of the 6. You have to count the number of students on that arm. Whenever you're asking for students to come up with a number, it has to be greater than that. You have to get off of the arm. So, for example, here we've got 9. So you can accept numbers 10 and above from your students. Okay, the second thing that you need to know is where the king is. So typically I get the students into this 9 or into this 6 pattern, and then I choose who to lay the robes of the king upon or the queen. So that you choose after you make your figure 9 or figure 6. How do you choose? Well, since it works for any number, you can choose any number that gets you off the arm. So in this case, I'm just going to choose 10. So I'm going to go, that's up to 10. And then I'm going to count the child that I ended on. I'm going to start counting on that same child again with 1. So let's see, that would get me right round to the king at 10. So just choose any number and do it. Enjoy this magic trick. 5s?
Yes.
Yes? What number would you like to count up to? 100 by 5s? That seems awfully difficult. Do you want to try? Okay, we're going to try going up to 100 by 5s. Are you ready? What do you think?
10.
It's less than 10. 12, it's less than 12. 12 is even more than 10. 10, 11, 12. So it's less than 10, definitely less than 12 too. Yes?
5.
5, it's more than 5.
6.
It's more than 6. It's more than 2. I mean, 6 is here and 2 is way down here. 2, 3, 4, 5, 6. So yeah, it's more than 2 and it's more than 6. 3, it's more than 3 too. 6 is up here, it's more than 6. So it's definitely more than 2, it's definitely more than 3, 4, 5, 6. Yeah. 9, you're right. 9 is my favorite number. I really like the number 9. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oh my goodness, who chose 25? Who chose 25? That was great. You got to the king. Twice in a row, you've got to the king. Wow.